Let's talk about solving radical equations. When you're solving radical equations, the very first thing you want to do is focus on isolating and then eliminating just one of the radicals. Now, in this example, there is only one of the radicals, so my first goal is to make sure that it is all alone on one side of the equation, which means that I have only the radical and there's nothing outside of it. There's no multiplying on the front, there's no adding or subtracting on either side. We have just the radical on one side of my equation. In this case, I do. So my next step is then to just take that entire side and square it, because squaring is the inverse of square rooting. So when I square, that eliminates the radical from the right-hand side of the equation. But of course, I have to also square the left-hand side of the equation as well. On the left, when I multiply this out, if you know how to square a binomial, you might recognize that this is just going to be x squared plus 2 times 1x plus 1. If you're not comfortable with that, then go ahead and take the x plus 1 and multiply it by a second factor of x plus 1. You can then FOIL if you use FOIL, or just distribute. X times x, x squared, x times 1 is 1x, and then I move on to my 1, and x give me x, 1 times 1 is 1, and then I can add these two linear terms to get x squared plus 2x plus 1. So same thing, two different approaches. On the right-hand side, I eliminated my radical, so all I have is what's underneath. We call that the radicand, and that is 7x plus 15. So at this point, there's a quadratic equation, which means I'll start by getting everything over to one side, so I have 0 on the right, and then I will solve from there. I subtract my 7x and my 15, so that there is nothing on the right, and on the left, I have my quadratic that I'm going to try to factor. Negative 14 does have two factors that add to negative 5, and those are negative 7 and 2. And because our leading coefficient is a 1, I can go ahead and just factor into x minus 7 and x plus 2. Since the product is 0, I know that my two solutions are going to be 7 or negative 2. We're looking at the x values that make each of those factors 0. Now, be careful with radicals, because radicals have certain domain restrictions. And if you did set up your domain in the beginning, you can just check this against your domain and make sure that you don't have any violations. We didn't do that, so we're going to now take these two values, go back and plug them in, and make sure that we don't have any problems. Let me clean this up, and then we'll go plug our solutions back in to check. First, I'll check my x equals 7. I plug it in everywhere there's an x. So I have 7 plus 1, and then 7 times 7 plus 15. I simplify each side separately. When you're checking, we're not allowed to bring things over from one side to the other. So on the left, I go ahead and add the 7 and the 1 to get 8, and I am hoping that that equals the right-hand side. I simplify under the radical first. 7 times 7 is 49, and then continuing under that radical, I have square root of 64, which is 8. So on the left, I had 8, and that does in fact equal 8, which means everything checks out. So x equals 7 is one of my solutions, and I'll go ahead and box it. Now I'll go ahead and do the same thing and check x equals negative 2. Plugging in that negative 2 everywhere there's an x, I have negative 2 plus 1, and then 7 times negative 2 plus 15. On the left, I add to get negative 1, and on the right, I simplify underneath the radical. Negative 14 plus 15 is square root of 1, which is 1. So the claim here is that on the left, I have a negative 1, and on the right, I have 1. So negative 1 equals 1? That doesn't make any sense. Negative 1 equals 1 is not a true statement, which means that x equals negative 2 is not a solution. We were able to get it as an answer, but our algebra doesn't take into consideration the fact that radicals have certain domain restrictions. So it's what we call an extraneous solution. It's an answer, but it doesn't actually work when we consider our domain restrictions. So our only solution here is x equals 7. And that's it. Thanks for watching, and I'll see you next time. Bye.